Material characterization play a vital role in understanding the properties and behavior of a wide range of material. By employing various techniques, scientists and engineers can gain valuable insight into the structure and composition of material, leading to improve performance, durability, and innovation across the industry. One powerful technique used for material characterization is X-ray diffraction, or XRD. XRD provides valuable information about the crystallographic structure and phase composition of material. By analyzing the diffraction pattern produced when X-rays interact with a material, researchers can determine its crystal structure, crystallographic orientation, and the presence of crystal defect. XRD works on principle of constructive interface of X-rays scattered by atoms in crystalline material. By the resulting diffractogram show peaks that correspond to the material crystal plane, revealing important information about its crystal structure, lattice perimeter, and phase composition. XRD find application in investigating residual stress, detecting impurities, identifying unknown material, and studying phase information. Another powerful technique in material characterization is Fourier transform infrared spectroscopy, or FTIR. FTIR provide insight into the molecular structure, functional group, and chemical composition of material. By measuring the absorption and transmission of infrared radiation, FTIR reveals specific vibrational modes and chemical bond present in a sample. FTIR spectroscopy is based on the fact that molecules absorb specific frequency of infrared radiation corresponding to its constituent atom vibration mode. By comparing spectral features of established libraries and database, researchers can identify functional group, determine chemical composition, and assess material quality and degradation. Raman spectroscopy is yet another powerful tool for material characterization. It provides information about molecular vibration, chemical bond, and crystal structure. Raman spectroscopy analyzes the inelastic scattering of monochromatic light to obtain a unique fingerprint of material vibrational mode and chemical composition. The Raman spectroscopy contains peaks that correspond to specific molecular vibration, enabling the identification of functional group and the characterization of crystal structure. Raman spectroscopy find application in analysis of organic and inorganic material, polymer material, and biological sample. Field emission scanning, electron microscopy, or FESEM. In a powerful technique for imaging and analyzing material at a nanoscale, it provides high resolution image and enable detailed examination of a material's surface morphology, topography, and element composition. FESEM use a focus beam of high energy electron to interact with a sample surface, generating secondary electron, scattering electron, and characteristic X-ray. This technique allows for examination of features such as surface roughness, crack, and grain boundary. Additionally, FESEM combined with energy depressive X-ray spectroscopy provide element analysis and mapping, revealing the composition and distributing the element with a sample.
Assalamualaikum, to my channel Dr. Intan. Today I would like to present standard procedure about my process technique. For sample 21 is plate component that involves X-ray diffraction, Fourier transform infrared stereoscopy, Raman stereoscopy. For the sample 4 is powder glass. That involves the technique is X-ray diffraction, Fourier transform, infrared stereoscopy, and field emission scanning electron microscopy. I summarize that the procedure process all technique is start preparing of sample, instrument calibration, sample measurement, data acquisition, data analysis, and that's all for me. Thank you.
Hi and Assalamualaikum. I'm Fiazi bin Samad. Now my turn to present about data analysis. On our task, we have provided two samples, sample 4 and sample 21. For sample 4, we use FSM, FTIR and SRD for the material characterization. FSM, from the image, we can see that the morphology for this sample 4 is sharp and varied morphology, and this use parameter 2000 and SE mod. For FTIR, at 1000 or 1000 and 771 per centimeter, have high bonding of silicon compound. And for the SRD, at 26, 27 and 28 have sharper and narrower peaks similar with silicon peaks. For sample 21, we use SRD, Raman and FTIR. For SRD, at 35 degree was the higher peak than other than this peak have been sharper and narrow peak, which have high crystallinity of carbon steel. And for the Raman, at 1111, 1559, 1596, 1770 and 1767 per centimeter reveal the peak of the carbon steel. And for the FTIR, at 1700 per centimeter have high carbonyl group. That's all for me, and I will pass to our presenter.
Hi and Assalamualaikum. My name is Muhammad Fidaus. I will continue the presentation. We present about discussion for sample 4 and sample 21. So sample 4 is about the powder and sample 21 is about carbon steel metal. Okay. For sample 4 powder, we'll use FSM, FTIR and XRD analysis. So I will explain one by one. FSM, the porosity can rise as capillary pores decrease. And then the thermal conductivity can increase the density. The effect about the density. This from an article nursery, which says water fills empty pores, increasing powder density and sample volume. Okay, and next for FTIR. So this method confirmed the sample presents and investigated its chemical bonding. So from article, Johnny says silica absorb water molecules from the atmosphere to create the sample. Then the sample can survive because it can raise water temperature. The last one is about SRD. So this one is from article. Jimenez Carbo found that surface crystallization makes the sample particular surface area work as a nucleating agent. Then as particle size and particular surface area go, the exothermic peak lowers, and this one it match the 0107C and 0941 difference for the sample. Next about sample 21. So sample 21 will use SRD, Raman and FTIR analysis. So the first one is about SRD. Their diffraction patterns represent the crystal formations. And then from Dewey Vedi, this is from article, says that phase analysis and this method could characterize carbon steel phase. Okay. Next, about Raman. Raman, for this method, can evaluate one or several layers of surface features. So this can analyze the metal plate. Next, surface enhanced Raman spectroscopy may be useful for analyzing solid liquid interaction according to DVD. And then Raman spectroscopy can qualitatively analyze surface films and their crystallinity. The last one is about FTIR. So conventional mid-IR FTIR has been utilized to analyze carbon steel surface coating. This is from the UAD, from article. So in corrosion setting, thin surface layers on carbon steel make it rougher, which limits the use of FTIR on its surface. So that's all from me. I will pass to the next presenter. Thank you very much.
Hi, Assalamualaikum. My name is Muhammad Azitamin Zubir Madan. I will present my part is conclusion for sample 4 and 21. Okay, for the conclusion for sample 4, the important detail of the composite for the conclusion is sample 4 is more to powder glass as a glass. The important detail of composite physical, thermal, mechanical and optical properties of the powder glass are reliable by material characterization process. The first chemical analysis, the powder glass instead precise of the number of oxides including silica, soda, lime and alumina and others. For the characterization procedure also give us important information about the shape and particle size distribution of the powder glass. Understanding how glass behave during a heating and cooling process, including its meeting temperature, glass transition temperature, thermal expansion, convection and thermal conductivity. For the second sample is sample 21 for carbon steel. Characterization of carbon steel is material offer important detail regarding composite, microstructure, mechanical characteristic, hardness, wear resistance, ductility, thermal conductivity and magnetic properties, corrosion resistance and weldability. Composite analysis, carbon steel is a large made of the element iron and carbon, minor amount of additional element including silicon, magnesium and inability amount of sulfur and phosphorus. Microscopic analysis reliable that carbon steel has a crystalline microstructure composed of the face, surface and pellet and surface. Carbon steel had a good hardness, making it effective for its required resistance to wear and emission. That's all. Thank you.